All right, guys, let's finish up the lesson. All right, next one's 7 pi over 6. In our thoughts, what we need to realize is what quadrant it is. 7 pi over 6 is a little bit over 1 pi. So it's going to be over here in my third quadrant. In my third quadrant, everything's negative. And my reference angle, pi over 6, is always square root of 3 over 2 1/2. All right, that's our thought process. At any point we're going through this, pause it, work ahead of me. All right, so I'm going to say sine, negative 1/2. Cosine, negative square root of 3 over 2. Tangent I may have to think of, but I know cosecant is going to be negative 2, and my secant is going to be negative, whatever that is. All right, so I'm going to say negative 1/2 divided by negative square root of 3 over 2. I'll make it positive, 1/2 times 2 over the square root of 3, which is 1 over the square root of 3. And I'm going to remember this right here, because that's what tangent is. 1 over the square root of 3. All right, there's something good. And then I'm going to take that and multiply it by the square root of 3 over the square root of 3 and get square root of 3 over 3. All right, cosine is going to be negative 2 over the square root of 3. Clean it up. And I get secant to be negative 2 square root of 3 over 3. All right, now tangent. This math here is my tangent. All right, so I'm going to take the reciprocal of my tangent, which is square root of 3 over 3. But what I'm going to use is this, because that is tangent, it's just not cleaned up. So I'm going to take the reciprocal of this, and so my cotangent square root of 3. I could take the reciprocal of this and do all this work, but I don't need to. This is what it is, which cleans up to this. So I'm just going to use 1 over the square root of 3. But if we look, let's go back. These 6 answers are these 6 answers in different places. These switched, which made these switch, which made those switch. So all your pi over 6s and pi over 3s are going to have the same 6 numbers. You just have to figure out where they go. One tangent's going to be square root of 3 over 3 and square root of 3. And cotangent, you just got to figure out which order it is based on how this cleans up a little bit. All right, a periodic function. We've talked about this a little bit without really using the terminology. A function f is periodic if there exists a positive real number c for all the t in the domain of f. Makes no sense, but we'll go with that. And I'm going to say that sine and cosine functions are periodic and have a period of 2 pi. So if we look at our unit circle, okay, our angles don't matter how we get there, it's where we end up. So on my unit circle, I'm going to have all of these answers from 0 to 2 pi. Starting at 0 and going to 2 pi, I'm going to have all those answers that we wrote down. If I go around again from 2 pi to 4 pi, I'm going to use those same answers over, because it matters where you end. From 4 pi to 6 pi, it's the same circle's answers. So a periodic function is saying it doesn't matter how many times you go around or which way you go. All that matters is where you end up. So every 2 pi, I'm going to keep using the same set of answers. So what we can do is pretty much ignore full rotations. So what I'm going to do is I'm going to take 17 pi over 6, which has a full rotation in it, with 12 pi over 6, which is my 2 pi, and an additional 5 pi over 6. So if I take 17 pi over 6 apart into 12 pi over 6 plus 5 pi over 6, which is going around and ending at 5 pi over 6, I'm going to ignore that full rotation. Okay. This graph here, this first part isn't important. All that's important is where I end up. So 5 pi over 6 is in the second quadrant, which is a negative positive. All my pi over 6s are square root of 3 over 2 1/2. So that tells me my sine is 1/2. My cosine is negative square root of 3 over 2. So when we talk about doing these in periods, we're going to ignore full rotations. Because I don't need to know how I get there, I just need to know where I end up. All right, for number 6, negative 9 pi over 2. I'm going to take this apart and get rid of full rotation. I'm going to put the negative on the outside just so it doesn't confuse me any. All right, negative 9 pi over 2. Well, full rotation in this is going to be 4 pi over 2. So I'm going to make this 4 pi over 2 plus 4 pi over 2, which is 8 pi over 2, plus an additional pi over 2. So what I'm doing is I'm recognizing how many full rotations I have in this. So what I'm going to do is I'm going to rotate down 1 circle, 2 circles, and pi over 2s. But those aren't important, so all I'm really going to think about is negative pi over 2. Negative pi over 2 is rotating down pi over 2, which is my ordered pair of 0, negative 1, which gives me my sine and gives me my cosine. If your angle is larger than pi over 2, more than one rotation, ignore the rotations and only really be concerned with where you end up. All right, this gets a little confusing for people, but all we are going to do is we're going to manipulate where my angle is by using just different values and different signs. All right, so draw this, and what we're going to do is we're going to figure it out. We're going to have 4 angles. All 4 angles are going to be based off of this angle theta. And what we're going to do is we're going to see what happens when I go from theta to negative theta, pi plus theta, and pi minus theta. So we're going to see how my answers change from one angle to manipulating it by making it negative or adding pi and stuff like that. Okay, so what we're going to do, now, like I said, I keep saying, pause this at any point. Don't just listen and then try to go back and figure it all out. If I have some angle theta, it could be anywhere. Okay, it could be first, second, third, or fourth. We're going to use first just to make it easy. All right, so if I have this angle theta in the first quadrant, my ordered pair is going to be a positive and a positive. So I'm going to say that my sine is positive, my cosine is positive, my tangent's also positive. And we're going to do those 3 angles on the left, negative theta, pi plus theta, and pi minus theta, and see what changes and where I end up. Okay? So let's go to negative theta first. Negative theta is an angle, and if I were to graph negative theta in relation to this one, it's going to be the angle down here in the 4th quadrant. If I was in the second, I'd be in the third. It just flips over the x-axis. All right, so what happens is, if my angle goes down here to the 4th quadrant, in the 4th quadrant, my ordered pairs are positive, negative. So my sine's negative, my cosine's positive, and my tangent's negative. So if I go from theta to negative theta, if I go from the top to the bottom, what happens is my y's change. My x's will stay the same, my y's will change, which means my sine and tangent change. That's what we need to understand. If I go from an angle theta, which is on the top, to my angle theta, negative theta, which is on the bottom, that's a reflection over the x-axis, which changes my y values. My cosine is going to stay the same, but my sine and tangent are going to become the opposite. From theta to negative theta, that goes from the top to the bottom to the top. My y's change, and anything that has a y in it, like sine and tangent change. That's our thoughts. Let's try another one. Let's go with pi plus theta. Okay, if I have some angle theta and I add pi to it, pi is half a rotation, so this, all the way to here, is going to be pi plus theta. Because if I have an angle theta and I add pi to it, I'm going to go halfway around. If I started in the first, I end up in the third. If I was in the fourth, I'm going to end up in the second. I'm going reflecting through the origin, halfway around. So if I go halfway around, I'm in the third quadrant. My sine's negative. My cosine's negative. But my tangent comes out to be positive. The sine over cosine would be positive. So if I go from theta to pi plus theta, my x's change and my y's change. So that means my sine and cosine changes, but my tangent stays the same, because if I change both, it doesn't change my tangent. So if I start in a quadrant and I rotate halfway around by adding pi, my x changes from the top to the bottom, my x's change from the left to the right, my y's change from the top to the bottom, but if I change both, my tangent stays the same. So from theta to pi plus theta, halfway around that unit circle, your sine and your cosine changes, but your tangent stays the same. And once we go over this and we do some problems, hopefully it'll make a little more sense. All right, last one. If I go from this angle theta to pi minus theta, what that means is I'm going to rotate to pi all the way over, but I'm going to back up that angle theta. So I'm going to rotate halfway around, but I'm going to go backwards at angle theta. And what that happens is I'm going to end up with a reflection over the y-axis. All right. Theta to negative theta is a reflection over x. From theta to pi plus theta is through the origin, or reflection over both of them. And pi minus theta is going to be a reflection over y. When I go from the first to the second, from theta to pi minus theta, over here in the second, my sine is positive, my cosine is negative, and my tangent of positive over negative is also negative. So from theta to pi minus theta is a reflection over the y-axis, which changes my x, which changes cosine and tangent. So that's the idea we need to know and understand. From pi to negative pi, let me start over again, that's the wrong word. From theta to negative theta is from the top to the bottom. When I go from the top to the bottom or bottom to the top, my y's change, which is going to change my sine and my tangent. When I go from theta to pi minus theta, that's a reflection over y, which means my x's change, which changes my cosine and my tangent. When I go from theta to pi plus theta, I'm going halfway around. So both the sine and the cosine change because my x and y's change, but my tangent stays the same since they both change. All right, maybe a little confusing, okay, but let's see how this is going to work. All right, so I'm going to give you the sine of an angle theta is 2/3. Okay, sine of an angle theta is 2/3. So since my sine is positive, I'm just going to draw some angle theta that has a y value that's positive. And I'm going to call it this theta. All right, where my sine is something comma 2/3 for my ordered pair. So sine of theta is 2/3. I'm going to draw some angle theta, and I'm going to try to keep it in the first if I can or second, that has a y value of 2/3. And that's what I'm at. All right, so now I want to know what the sine of theta plus pi is. Theta plus pi is I'm going to take this angle theta and add pi to it. It's going to put me down here in the second or the third quadrant because I took my theta and I added pi, which is a half a rotation. If I'm down here, my sine is negative because I'm in this third quadrant, which means my sine is going to have the same value But instead of it being 2/3, it's going to be negative 2/3. Because I took that angle from the first and I rotated it to the third. So that means my y value changes, which means my sine of what theta used to be is going to be the opposite. All right, sine of negative theta. If this is theta, if I draw negative theta in relation to this, that's negative theta. Sine of theta is 2/3 in the first, and now I'm in the fourth, and I know in the fourth my y value is now negative. So I can say that the sine of negative theta is also going to be negative 2/3 because I went from the first down to the fourth. If this answer was negative to begin with, it would become positive because I moved from the top to the bottom, bottom to the top. Because we said from theta to negative theta, my y's change, so my sine and my tangent change. This last one we did from theta to pi plus theta, both the x and the y change, so both the sine and the cosine change. And cosecant of theta, which I had to move, is just a reciprocal of this original one, which is 3/2. So what we have to recognize, I said it a little bit, is how theta changes when I do theta plus pi, negative theta, pi minus theta, and all that stuff. We just got to figure out how it changes. If I was in the first, where am I now? All right, we'll do cosine of theta is negative 4/7. All right, cosine of theta is negative 4/7. When cosine is negative, which is my x value, I'm going to be in the third, or second, or the third, because that's where my x values are negative. So I'm just going to draw it here. So this is my theta. All right, we're going to go from there. So this ordered pair is negative 4/7. Something, I don't care, it's not important. All right, so now I'm changing my theta to my pi minus theta. So I'm going to go back, and when I change theta to pi minus theta, we said that was a reflection over my y-axis. And when I reflect over y, my x change, which cosine and tangent change. So now pi minus theta is going to be here. And when I go from the second quadrant into the first, my x's change, and anything that has to do with an x. So if the cosine of theta is negative 4/7 here, it's going to be a positive 4/7 in the first. Because when you do theta to pi minus theta, it's a reflection over the x or the y-axis. All right, secant is the reciprocal. So I'm just going to take the reciprocal of cosine. All right, the last bit on this one, I want secant of theta plus 2 pi. I didn't talk about that on the last screen, theta plus 2 pi, but if we go back another page, we talked about if I have an additional rotation of 2 pi, it doesn't make a difference because you end up where you were. So secant of theta plus 2 pi is the same as the secant of theta. Because when I go back a couple slides, we got rid of full rotations and made them unimportant. All right, so you just have to recognize how changing these changes them. Theta to negative theta, reflection over x. Theta to pi minus theta, reflection over y. Theta to pi plus theta is a reflection through the origin, or both of them. Reflect down, reflect to the side. Reflect to the side, reflect down. And that's going to tell you if it was positive and if it's going to become negative or stay positive. All right, last one. We're going to do this with the calculator. Okay, I'm going to try to see if I can do a split screen here to make it a little bit better so you can see it a little bit easier. All right. All right, so let me try this again. I'll put this over here. All right, so I'm going to find the sine of 30 degrees. Let's see if I can make this work so we can see it. All right, sine of 30 degrees. If you have a calculator, use a calculator, but if you want to use decimals, because that's where we're at. All right, so let's do this in our heads first, or on paper first. Sine of 30 degrees. A 30-degree angle is going to be here, which is the same as pi over 6. Okay, we're going to get to the calculator in a minute. 30 degrees and pi over 6 are the same. We know that pi over 6 is square root of 3 over 2½ So the sine of pi over 6 is my y value, which should be 1/2. All right. So let's see what happens. So I'm going to type in the sine, parentheses, of 30. And I get this, which is not what we said of 1/2. Okay? So my first thought may be is if I do this, let's do it again. Let's use our functions and do the sine of 30. See if that makes a difference. And it doesn't. All right, so we have an issue. All right. When I type in sine of 30, I don't get that same answer. But what we have to do, I don't know why it's doing that. All right. Make this a little smaller, make it a little bit easier to deal with because we don't need the graph itself. All right. We need to change to degrees. That's the big thing. Calculator and Desmos. I want to talk degrees, not radians. So now if I get rid of that, I get my sine to be 1/2, 0.5. All right, so the biggest thing here is understanding that you need to be in the right mode. And to change your mode, you hit the little wrench. All right, so number 10, the cosine of 15 degrees, 12 minutes and 17 seconds. So I can do my functions. Cosine, whoa, minutes and seconds. I don't remember that offhand. And that's probably what a lot of you guys think. But we need to remember, I'm going to do a cosine of 15 plus my minutes divided by 60 plus my seconds divided by 3,600. That was on our homework. And when I close that up, I'm going to get my answer. Remember, minutes over 60. Seconds over 3,600. So I need to add cosine of 15 plus 12 over 60 plus 17 over 3,600, and I get my answer. All right, so this is just knowing how to plug it in right. All right, so that's number 10. All right, I'm not going to write them down because you can see them up here. All right, secant of 98 degrees. So I'm just going to go over here and say the secant of 98 degrees. And I get negative 7.185. Remember, round to 3 decimal places. I take off if you don't. All right, if you're on a calculator, and at some point we're probably going to have to be able to do this on a calculator, we have talked about the secant being the reciprocal of cosine. So the secant of 98 degrees is the same as 1 divided by the cosine of 98. And I get the same answer. So if you do not have a secant button on your calculator, you don't have access to Desmos. To find the secant, we're going to do the reciprocal of cosine. So I'm going to do 1 over the cosine of 98. If I wanted cosecant, it would be 1 over the sine. Cotangent would be 1 over the tangent of that value. All right. The next one, number 12, sine of pi over 5 is not in our unit circle. And I'm going to get this, which I'm going to tell you isn't right, because we have an issue. When I do the sine of pi over 5, I need to go back to radians. And you get 0.588. Go back and forth. Number 13, the tangent of 13 pi over 6, we can look at our unit circle for that, but using a calculator, functions, tangent. I'm just going to write 13 and type pi. divided by 6, and I get my answer. All right, so for 9 through 13 on the board, make sure you're in the right mode, however you're doing it. Make sure you round to 3 decimal places. Number 11, the secant. Can you do secant of 98? In Desmos, on your calculator, you need to do 1 over the cosine of 98. It's going to get you to the same place. Don't try to do secant in your calculator without doing 1 over the cosine. Nothing else works. All right, so that's the rest of the lesson for today. Make sure you have this done by class and understand it. If you need to come to tutoring, come on Fridays at 12:20. If you have any other questions, send me a message. Email me. I'll answer as soon as I can. All right, have a good one.